Hi everyone, here's a quick video on how to do this week's tests in SPSS. So we're in chapter 8 of our textbook talking about repeated measures ANOVA and the Friedmans ANOVA. These are the tests we use when we have more than two dependent groups, or a common example of this research design is we're testing the same people 3 times or even more. So we can't use our repeated measures t-test like we did when we had 2 dependent groups. Now we have to use either the repeated measures ANOVA or the Friedmans ANOVA. So here we go, opening up the data set. I'll use the example data set here, and this is looking at, I'll click over variable view so we can see the day 1 symptom level, day 2, and day 3. So there was a rating of these 13 patients on days 1, 2, and 3 of their symptom level, and we're looking to see if there was a change from day 1 to day 3. So that's our research question. Our null hypothesis would be there is no change in symptom level between days 1, 2, and 3. And the alternative would be yes, there is a difference. There is a significant difference in symptom level. So to test that, to help us decide which of those hypotheses we choose, we will run first the repeated measures ANOVA, and then we'll go through the same steps for the Friedmans ANOVA, the non-parametric version of the test. So here we go. First let's make some histograms. So graphs, legacy dialogues, histogram. I'll hit reset here to start over. We just hit day 1 symptom level, put it over as our variable, and just say OK. And there's our day 1 symptom level. And then we'll do that again for day 2 symptom level. And then one more time to make a histogram of our day 3 symptom level. There we go. Day 2 looks like it was more normally distributed than days 1 and 3. This one has a right skew. Not sure what to say about this one. They're close enough to normal though that we could still be comfortable with running the ANOVA. So after we've made our histograms, to run the ANOVA, we'd go Analyze, General Linear Model is where we go to our repeated measures option. And we will rename this within subject factor name. We're going to call this day, because let's switch over here to back to the data set. There were 3 days. Where's my dialog box? There we are. So we had 3 levels. That's what we have to put in. Click Add, and then we say Define. We have to tell it, so now it knows that there was 3 levels, and now we have to say which variable goes with each level. So we bring day 1 over to that first level, day 2, and then day 3. And then here in the this list of buttons, we'll click Options and ask it for the descriptive statistics, and then we will say OK. It gives us a lot of information. This first box saying that day 1, 2, 3 was matched up with variable day 1, day 2, day 3. Here's our means and standard deviations on each day. It looks like there is a significant difference between day 1 and day 3, just looking at these means. And then day 2 and 3 also seem very different. But we'll come down here, skipping this table and also this one. So we'll come to this table of tests of within subjects effects, where we will, just for the purposes of this class, always look at the sphericity assumed line. So this is the F value that we would report and our significance level. So since it's calculated to 0.000, that's less than 0.05, so we would say that we can reject our null hypothesis and conclude that there is a difference in symptom severity for these patients on day 1, day 2, and day 3. The question we can't answer, however, is which of the means is different from the others. For that, we'd have to run post hoc tests, and we are going to skip that this week. SPSS does not do that very easily. It's beyond this class, so we'll just have to say for now that there was a difference, and we'll leave it at that. We won't try to say that day 1 was different than day 2 or day 3. Let's see. So how we would write this up is bring over this window in Word and say there was a significant difference in symptom severity level between day 1, day 2, day 3, and day 3. So after getting that written in, we need to then fill in the numbers to support that statement. So here's our descriptive statistics box. So after day 1, M equals 8.69, comma, SD equals this number 1.03. So we do that for each of the days, and then after the day 3, I'm just going quick here, so I'm not going to fill these in completely. I'll just put the M equals, SD equals for each one, just as placeholders. Day 3 we have mean and SD. Alright, then we'd have comma, and we have to put in the results of the F test. So we'd have F, and then in parentheses the degrees of freedom, which for this test, remember we're looking at sphericity assumed, so we put in the degrees of freedom for that test, which was 2, comma, and then we put in the degrees of freedom for the error, so that'd be 24. So it's the sphericity assumed at both levels, both places here. So that's our degrees of freedom. So the F equals, and then we put in this F value, 65.06. And comma P equals, and then here's that P value, 0.000. Period. Alright, so that's how you'd report your results for this research. Just a quick recap, you would say there was a significant difference in symptom severity between days 1, 2, and 3, and then you put in the numbers to support that conclusion. All right? Okay, so that was the repeated measures of ANOVA. The Friedmans ANOVA test is done very similarly under Analyze. We'll just do it on the same data set, just for illustration purposes. So non-parametric tests, pick the legacy dialog so we can say k related samples. In this case, k just means some number of samples that are related. So it's some number more than 2. This test is a little easier to run because we can just bring over our days as the test variables. We don't have to declare the factor levels like we did. We hit the statistics button so we can tell it to give us descriptive statistics and then say OK. And it adds to our output page. Here, the results of that test here are the descriptive statistics. So days 1, 2, and 3, their means and standard deviations. And then down here, you have the chi-square that this test calculates. So in this case, 22.17, 2 degrees of freedom, and our p-value here of 0. So this test also found that there was a significant difference between the groups. And you would write this up the same way, saying there was a significant difference in symptom severity between days 1, 2, and 3, and the means and standard deviations would all be the same, except here instead of this f value you do chi-square, which you can look up the value, or you can look up, did I misspell square? Oh, didn't like that. Gotcha. We're going to leave it like that anyway. So you can insert the chi symbol if you want, or you can just write out chi-square. That'll be fine. So here we have n of degrees of freedom of 2. So for this test, we just take that out. And then our calculated chi-square value, we would enter 22.17. P equals 0.000. So once again, though, the idea is to say it with words that there was a significant difference in the symptom severity level, and then to back it up with the results of your test. All right, so there you go. Hope that helps. We'll be talking about it in class this week. Let us know if you have any questions.